I'm going to start the recording. Yeah, we're good to go. All right, so this is our first collab session. What I want to basically focus this session on is kind of assisting you in finding your way around this module, where to access resources, how to kind of pace yourself, where to find relevant material, the calculator, assessments, and how to calculate your final mark if you want to do that. All right, so let's start with the first point, which is the calculator. I would recommend that you get a Casio calculator. I'm going to share my screen, but if you don't see it, give me a second, I'll tell you once I'm sharing it. Okay, I'm going to start sharing now, and I'm going to show you an image of the calculator. If you can't see this image, please let me know. So this is the calculator I would prefer that you get. It's a lot easier to use. It's very user-friendly. It has a good display. And I'm actually better able to assist you with this one. I can assist you with the shop, but it's not that, I would say it's not my forte. But if you're stuck and you can't get another calculator, then yeah, I'll assist you. But I encourage you to get this one for a couple of reasons. As I said, it's easier to use, but it's quick to use. And when you're writing the exam, time is against you. So you'd want to get a tool that enables you to get through the paper as fast as possible. So encourage you to get this one. All right, so please get this calculator. Once you get it, on the VCLearn platform, there's some resources on how to use it. So I'm going to go there now. So if you look at my screen, on the left, you should see more resources. And under more resources, you will see here, using the calculator, you can click on that, and then there's an additional calculator resource. So you can click on those two and read through it, practice with your calculator. It's very important that you become proficient with it. But we're not going to use the calculator today. We're going to start using it from the following sessions where we're going to start doing calculations. Today is more theory-based session for this course. And learning unit 1 is basically the only learning unit where it's very theory-based. The rest of it, it's a lot of calculations. All right, so you'll be, yeah, pen to page, solving equations using your calculator. All right. So I'm just going to pause there for a second. Anyone didn't follow anything or couldn't see what I was showing on my screen in terms of the calculator resource and the recommended calculator, please let me know. I'm just going to come back to VCLearn and check if everyone's okay. If there's any questions, I'll wait for a few seconds and I'll move on to the next point. All right, so I'm hoping that you kind of followed what I was saying of the calculator. Yeah, and how to start using it. All right, the next point is the resources that you want to have at your disposal. Right, so there's two things you want to have right now, which is your module outline and your workbook, and these can be found under more resources. And then if you go under more resources, you'll see module outline and workbook. If you click here, you'll have these two PDFs. As far as I know, I think the module outline is in a Word document, but I put last year's one, which is in a PDF format. So it should still be fine. What you want to take away from the module outline is the weightings of your assessments, basically what percent carries towards your assignments and your ICE and your exam, as well as the module pacer. Okay, the pacer tells you what learning unit you need to be at for that respective week. So in week 1, you need to be, say, at learning unit 1, and week 2, maybe you still need to be at learning unit 1, or you need to be at learning unit 2, but the pacer is in your module outline. All right, so get that, and you can follow that as the pacer. The workbook, and I've got it open because I'm going to use it now to kind of show you where to get exercises that you can revise from. So if you open this workbook, there's a lot of activities which I encourage you to work through. I'll give you some activities to work through at the end of this session, specifically for Learning Unit 1. But I'll only give you a couple of them. I encourage you to work through all of them. Right? It's a very great resource to consolidate your work and to ensure that, to point out whether you're actually understanding the material, right? Because if you can work through this, you're on the right track, right? So it has exercises and revision exercise, should I say, for all learning units, all right? So get those two resources, your workbook and your module outline, right? On VCLearn, how to navigate through it, okay? So on the platform itself, there are other resources. So if you go here on the left, module content, learning units, right? You can see here that it'll have all your different learning units, 1, 2, 3, etc. If you click on each of them, so let's look at learning unit 1, for instance, introduction to statistics. If you click on that, it'll give you a lot of themes that you can go through. For instance, theme 1, introduction to statistics. If I click there, you can see it'll give you, it'll highlight the topics specifically in bold on to understand what you need to cover. I think I got a message. I'm just going to check the chat. No, I'm all good. All right. So give me 1 second. All right. In here, under learning units in module content, it will tell you what chapters in your textbook are relevant for that specific learning unit. Now, I just want to point this out to you and make sure you understand this. Your learning unit numbers do not correspond with the textbook chapters, okay? Just because it's learning unit 2, for instance, doesn't mean it corresponds to chapter 2 of the textbook. Okay, it doesn't always work like that. And if you're confused which chapter is linked to it, go to here where I'm showing you under your learning units. So for instance, I clicked on learning unit 1. It'll tell you here, refer to chapter 1 in your textbook. So the different learning units, if I go back here, learning units, if you go back to, let's say, let's look at learning unit 2, for instance, index numbers. If you click here, and if you start reading all these themes, let's just click on the theme here, theme 1, index numbers. You can see it tells you to refer to chapter 14 of your textbook. So learning unit 2 is chapter 14. Okay, so that's how you can determine which chapter corresponds to that learning unit. Okay, so I'll just pause there for a second and check if there's any questions. If you can just give me a thumbs up that you're all good, I'll move on to the next point. Otherwise, happy to explain further. Feedback is highly appreciated, everyone. Give me a thumbs up. You're good? Okay, cool. Thank you. Thank you. Thanks so much, everyone. All right, so next point, how to calculate your final mark. Now, I have made this Excel available to you. Okay, so this screenshot that I'm putting on this Excel, I got this from your module outline, which I mentioned earlier. You can find it there, all right? So for instance, if you click there, you'd have assignment 1 and assignment 2 instead, right? Instead of test 1 and test 2, because you're distance learning. But the procedure is the same here, all right? So if you see this table that I put here, I've kind of done all the work for you. So the only thing you need to enter here is your marks in this column that's highlighted in green. Now I've made this Excel available to you. I'll show you where to access it in a second, but I just want to take you through it so you understand how it works, right? So you will enter your mark for your assignment 1 as a % here. Oh, got a message. Have the assignments already been uploaded? Marty, I'm not really sure. Yeah, I'm not really sure about that. Just have a look. If you don't see it, it might be too early. So yeah, if there is going to be an issue, I will let you know, but I haven't heard anything. All right, so let's go back to this Excel. So if you punch in your mark for assignment 1, so say you got 65%, so you'll enter that here. For assignment 2, let's say you got 60%. Okay, so I'm going to put 60% there. There you go. Remember, your mark should be out of 100% here, right? For assignment 1 and assignment 2. Your ICE, now here, I want you to put your average mark. So you're going to have 4 ICE tasks, all right? So say, for instance, for ICE task 1, you got 70%, ICE task 2, you got 75, IS3 you got 68, and IS4 you got 80%. So you would average them. So basically add up all the percentages, add them all up, and divide by 4 because you have 4 I-stars, and that gives you an average of 73%. That is what you will enter here, your average. Okay, so enter your average here, and then your exam, you would enter your mark here, and this will automatically be calculated for you. That's your final mark. Okay, so if you had got all these marks for your assessments, your final mark would be 66%. All right, so say, for instance, okay, just one more point. Your exam, you need to have a sub minimum of 48. Okay, so even if your class marks for assignment 1, 2, and your ICE marks are, like, say you scored 100% for all of it, right? You still need to get at least 48% for your exam, no matter how high your CAS mark is, basically the marks for your assessments. All right, you must have a minimum of 48%. So note that. If you're not sure what you need to pass, so say you need 50% to pass, right? You need this red mark to be 50%. So you can just start, say you finish all your assignments and your ICE, and you want to determine, okay, what do I need to get in the exam to get 50%? You can just play around with the marks. So you can go 60%. What do they give? Okay, that'll give me 63. So you can go 50%. That'll give you that. And remember, you can't go lower than 48, right? So 48 is the lowest you can get. And if you get 48%, then you will pass the course. All right, I hope that makes sense. That's how you'd use this Excel. All right, you just need to enter the marks here in this green column, and it'll give you your final mark here in red. I've made this available for you under more resources as well. So if you go here, more resources, and under final mark calculator, if you click here, you can download this Excel and you can use it as a template, right, to help you calculate your mark. Okay, so the weights here I've entered it for you, because if you go to your module outline, you'll see what your weights are for assignment 1 and assignment 2. If it is different, change it. All you need to do is change. Say your weighting is 30% in your module outline. What you see there, this changes to 30%, and that'll do everything for you. Okay. But as far as I know, these are the weightings that you have for assignment 1, 2, and your ICE marks. Right, and that's your exam weighting. All right. Let's check if there's any questions. No, you're welcome. I hope that'll help. So that's how you'll calculate your final mark. All right. The next point I want to cover. This is okay. So the next part is basically starting with learning unit 1. All right. So I'm going to start with learning unit 1. In my opinion, learning unit 1 is kind of like the terminology and the theory behind it. It's not the fun part, to be honest. The calculations are actually I find more stimulating, and also it's much more hands-on. Right. So unfortunately, you do have to understand the dreaded terminology behind stats. But before I start, let me try and kind of explain, why are we doing statistics, right? What is the purpose of it? What value can it add to your life? All right. So let me just no, I'm not going to close this Excel. I'm going to open up a whiteboard. Okay. All right, so let me try and give you an example of where statistics comes in. All right, it is pretty much used in everyday life. So let's just look at if you bought a packet of chips, potato chips from the supermarket, right? So I haven't bought a packet of chips in a while, so I don't really pay attention to the grams, but let's say it's around 40 grams, right? That's what it says on the packaging. So the packet of chips says 40 grams on the packet. But the thing is, if you actually take a number of those packets of chips and you put them on a scale is very accurate, right? That measures things to maybe to 0.001 grams. It measures it to that accuracy, all right? You'll find that sometimes some packets will not be exactly 40. Some will be maybe 39.05. Another one may be a little bit more, maybe 40.1, for instance. All right. So even though the packet says 40 grams, there is variance. There is a deviation to what it actually states. But the question is, at what point can that manufacturer of those chips say that it is 40 grams, even though there is that deviation. So are they allowed to say if the packet had 37 grams, are they allowed to say that the packet is 40 grams, even though when you put the packet on the scale, it's actually 37 grams, all right? Statistics actually plays a role in that. Statistics tells you what is the limit, right? So for instance, you may come across something called confidence intervals. You actually won't deal with that. You'll actually deal with something very similar. I think I've got a message. I'm gonna come to the chat. Are these sessions recorded? Yes, they are. It's actually, this one's actually being recorded. Okay, I'll make them available afterwards. All right, so let me get back to where I was, the whiteboard. Right, so stats can actually determine, okay, what that limit is. All right, so I won't explain confidence intervals right now, but this is just what I'm trying to get for this session is where it's applied. All right, and then you'll also come across maybe claims in a paper or studies that say, you know, the results. Let's say, okay, in the pharmaceutical industry, all right, often they will claim that a drug or pill, tablets or whatever, um, basically does, let's say, improve concentration. Okay, so if you take this drug, it can improve your concentration, uh, and so and so. Or there's another one that says if you take this drug, it's can drop your weight. It can assist with weight loss. All right. Now, how can they make these claims? Okay, what they do is they do statistical trials. So what they can do is they can take one group of, let's say, test subjects, right, or basically patients, and say there's maybe 10 of them. So patient 1, 2, 3, all the way up to 10, right? And then they got another group. So I'll call this group 1. So I'm just going to put G1 here. And then the next group is G2, right? So G2, what they'll do is, for this group, they'll also have 10 patients, 2, 3, all the way up to 10, right? They've got 10 patients here. Now, for group 2, they'll give them the actual drug, okay? So here, they'll get the drug that they're testing. Group 1 would get maybe a placebo drug. A placebo drug is basically, you can think of it as a sugar tablet, but you don't tell these patients in group 1 that they're getting that, okay? You can give them a placebo tablet, like just a plain old sugar tablet. So I'm just going to write placebo. I hope my spelling is correct. Placebo. Okay. And they can tell them that this placebo drug is the real deal and it does reduce weight loss. So you'll give it to them and you can check whether, you know, it actually does reduce their weight versus the true drug on group 2, and you can check their change in weight. And statistics is used here to make that conclusion that the drug actually works or it doesn't. It's done scientifically. All right, so that's another way where statistics is used. I'll give you one more example where stats is used. I'm just going to try and use my pen here. Hopefully this is better than my mouse. All right, so let's say you've got two things that you're trying to look at, right? You're trying to determine, can I predict, let's say what you're trying to predict, right? Let's say we're trying to predict someone's weight. We want to try and, sorry, my bad. We're going to predict someone's height. So I'm going to write H-I-G, height here, based on their weight. So if someone comes in and I get their weight, I don't know what their height is, right? So I get their weight, and I record their heights, right? So I've got this sample of people. I'm just going to put dots here. So person 1, 2, 3. And what I find, it tends to be that people's weight, as it increases, they tend to be taller people, right? So what I want to do is I want to use this relationship to predict someone's height. So say someone comes in to the door here with this weight recorded at, let's say, 80 kgs. So this person's weight is 80 kgs. Based on this, based on that, I want to try and predict what this person's height is. Right? That is statistics used for prediction or forecasting. And you can think of other applications of this, whether people even do this for the stock price, sales. You know, if you want to forecast what your sales are going to be, statistics is used for that. Okay, so that kind of in a nutshell, that's just some of the applications of stats. This is kind of how it's used in everyday life and in industry. Are there any questions here? Did any of that make sense? I don't expect you to kind of understand this in detail. This whole idea here was to give you an overall picture that this is used somewhere and you're not just kind of just crunching numbers in this course. Um, I'll pause there for a second, check if I lost anyone, or you're all good with this, and I'll continue with the nitty-gritty of learning in one. Just give me a thumbs up if you're good, and I'll move on, or happy to explain what I just did. Okay, cool, great. All right, so let's move on to, I'm glad, thanks. Let's move on to learning in one. Okay, so what for learning in one, what I want you to read through is chapter 1 of your textbook. Okay, so chapter 1 covers learning in one. Once you've done that, read through the lecture slides. I will cover the material now, but I'm just telling you what to do once the session is over, um, what to look into to consolidate your work. So on the lecture slide, which is also under more resources, if you go here, and if you click your learn lecture slides, click on learning one and read through that slide as well. All right, so go to your textbook first and then supplement that material with learning in one. All right, and I'll give you some exercises to go through in your workbook to consolidate your work. All right, so let's begin with learning in one and what I want to cover. So I'm going to clear this board. All right, just give me a second. And I'll try and explain these concepts with an example, because I feel that will be the best way to kind of get you to understand, conceptualize what we're talking about, instead of just regurgitating what's in your textbook, all right, or in your lecture slides. Right. So the first thing that you want to kind of get a grasp on is the difference between a population and a sample. And this will be mentioned plenty of times in this learning unit, and it's very important that you understand what the difference is. Okay, so a population is basically the entire, I would say, um, group that you're looking at. So for instance, say you were interested in um, the average mark of all IIE students for this module across the country. All right. Now that is the population. Right. That's everyone that you can think of that is doing this course in for the IIE, under the IIE. Right. But maybe that's not feasible. Okay. There's just too many students across the country. It's not financially feasible to actually obtain the results from all these students. So what we can do is we can get a sample to represent them. So this is our population. This big circle is everyone across the country, right? But the sample is just going to be a smaller, uh, uh, I would say, subset of it. So we could just take maybe 20 students from Gauteng, 20 from the Western Cape, and 20 from KZN, hypothetically, right? Let's just take a few, and this would be the sample, right? Those 60 students, 20 from Gauteng, 20 from Western Cape, 20 from KZN. And that is doable, okay, because it's not too many, it's not too expensive to obtain those results, and maybe not too time consuming. Based on that, we could use the sample to kind of estimate what the population average is. Okay, so we can get the average from this sample, and I'm going to use symbols here because you're going to have to get familiar with it. X bar, this is an X with an horizontal line over it, means it's the average for this sample. So if I get the average mark of the 60 students, that would be my X bar. And I'm going to use X bar to estimate what the true average is of the population. And that symbol is mu. So mu is the true average, which I would love to know precisely, but because it's too expensive to obtain that result, I would use X bar to represent mu. All right, so mu is your population parameter, X bar is your sample statistic. Now, we don't only have to talk about averages, we can also talk about proportions. So for instance, let's just say I want to know what proportion of students are male, all right? So that isn't an average, that is a percentage of proportion. So also, just like before, I can't gather the information of all students across the country, right? I'd have to use the sample to estimate that. And so the proportion of males, I would represent that with this P, okay? P, and that'll be used to estimate the true proportion, which is given by the symbol pi. That's the true proportion. So these two correspond. We use P to estimate pi, and we use X bar to estimate mu, right? That deals with averages. There's a lot of other statistics and values that we can get from the sample to conclude about the population. All right, now you'll come across two terms for stats, right? You'll come across descriptive and you'll come across inferential. So I'm just going to write that here. You're going to come across descriptive stats, right? And you're going to come across inferential stats. And I'll explain the two in a nutshell here. All right. Now, descriptive stats, you can think of it as you're basically looking at this green circle. Everything having to do with this green circle, the sample. All right. So I can look at basically what the average is, right? How spread out this data is. Basically, when I say spread out, I mean how much deviation does the student's mark deviate from the average. So say the average mark is 65. If a lot of students get a mark, let's say at 30%, that's a much bigger deviation than if the students were getting closer to 59, right? So there's a smaller deviation. Now the deviation is shown by the symbol S here for the sample. And if I want to know what does the deviation of the true population is, I'd have to use S to represent the true deviation, which is sigma. All right, so these two correspond. And what I'm doing here is I'm using information from this green circle, the sample, to profile what the behavior or the data, or let's say what the true population is. Okay, where it's centralized, what the deviation is, how spread out the data is, and basically about outliers. Outliers are basically, you can think of students that, say most students got around 70% for the exam, but then you get these one or two students that get 100%. Those are considered outliers because they're very far away from the rest of the group. All right. Okay, so that's basically descriptive stats. We profile the sample data um, to kind of conclude the profile of the true population. Now, inferential stats is basically, infer is, you can think of it as estimating, all right? We're using these stats, these sample stats, this X bar, to estimate what mu is, okay? To infer what the true value is, right? We can also use this green circle to kind of determine how spread out the data is. So remember that example of the packet of chips that I told you. I've got a message. Yes, these sessions are recorded. All right, so I'm gonna go back. So remember that when I explained about the packet of chips, say you want to know, you want to draw a conclusion about the population of chips throughout the country. And that's definitely not going to be financially viable to get that information. So we use a sample to estimate that. Now, based on the sample, we can say a packet of chips is 40 grams plus or minus, or in other words, give or take 0.05 grams. Now, how I got that plus or minus 0.05 grams is I got it using the sample, using this green group here, right? Which was much easier to obtain than getting the actual true population. Now, based on that sample, I can say what that deviation is, that give or take of plus or minus 0.05 grams. So that's inferential stats. You use it to, you can draw limits, upper bounds and lower bounds on your true values, as well as to estimate what the true value is. I'm going to pause there just so to see that everyone's following, haven't lost anyone, and you kind of got the idea of the what I've just explained here in terms of the difference between descriptive stats and inferential stats, as well as the population and the sample. You can just give me a thumbs up or good. Okay, fantastic. All right, thanks. So the next part I'm gonna talk about, and this will kind of be the last part of this learning unit that I'm gonna discuss, is basically about data, random variables. I'm still struggling with inferential a bit. Okay, sure, Victor. So okay, um, inferential stats. Think of it as an estimate. Okay, so let's put it this way. I don't know the true value. So say I want to know the average, right? I want to know the average mark of students for this module across the country. Can I get a message? I'm checking. Okay, thank you. All right, I want to know the true value. Now the thing is, I can't know the true average, right? Because there's just too many students. Right? I'm only talking about South Africa. Let's say we were looking at international. There was just too many to kind of determine what the true value is, right? And so what I did is I take a sample. Now the sample is basically I can take maybe 100 students from 4 provinces, and I can use that to estimate what this mu is. But let's just say because I'm not taking everyone, this average that I get from the sample of these 400 students, this 100 students from each province, it's not going to be exactly equal to mu. But what I can say from the sample is I can say, okay, from the sample, I found from those 400 students, the average mark was 65%, right? But I can say with confidence that this true value here is around 65, give or take 5%. So I can say with confidence that this true value is it's between, what I'm saying is it's between 60, because it's 65 minus 5%, so it's between 60% and it's at most 70%. I've basically given it a bound, right? I'm inferring what the true value is based on what the sample is. So that is what we mean as an example of inferential, to use the sample to infer what the true value is. Does that make sense, Victor? Great, great. Okay, so I'm going to move on to the next part, which is data, random variables, etc. All right, so I'm going to also show that with an example, but I just want to give you a kind of a flow diagram of the different types of data and what they mean. Okay, now different types of data that you'll have is quantitative and qualitative. Right? I'll explain the difference here. So qualitative, let's see, qualitative, and then you're going to have quantitative. Right? All right. Okay. So another way you can think of qualitative is categorical. It's the same thing, right? And let me give you an example of what categorical is. Let's look at this Excel here. I'll put some dummy data here. Right? So what happened is here, we've captured data on different people. So the ID, this ID1 could be ID2 could be someone else, etc. All right. Those are different people. And what we have here, what we're capturing is basically our limit balance, right? So as in limit balance for my credit card. So my credit card has a limit of 20,000. Okay, so here it's female. Okay, let's say this is me. I'll make it male, right? So here captures information about me. My limit on my credit card is 20,000. That's my gender, my education. Now these numbers they could be, basically think of one as having a diploma, two maybe having a degree, three masters, etc. All right, that's what they could represent, right? That's what the numbers represent. Instead of writing out diploma, um, degree, masters, etc., we capture them as numbers, right? Marriage, straightforward, age, and your credit card usage. So I use on average 3,913 rands, right? And the next person, that's their information. Okay. Now, the qualitative I was talking about, the categorical variable. Now, each of these columns are variables. Okay, apart from the ID, because that's not really a variable, it's just an identifier. Everything else is a variable, right? Right. Now, categorical, you can think of gender here, right? Because you fall into a category. It isn't a number, right? You male or female or even other, right? So there's different categories here for gender. So that's an example of categorical variable, right? Education is another categorical variable, right? Even though it's a number, categorical. I'm gonna check if I have a message. Okay, cool. No, I'm coming back to Excel. All right, marriage, that's another example of categorical, okay? So that's qualitative as well. So when I'm coming back to this part here, as I mentioned, you get qualitative, which is another name for categorical. Under qualitative, there's two types you can have. There's two types of categorical variables you can have. You can have nominal, and I'll explain what that means in a second, and you can have ordinal. All right, let's look at nominal first. All right, nominal means there isn't an order. All right, so let me go back to this example here, and I'll show you which one is a nominal variable. When I say there's no order, there's no such thing as one value being higher or lower than the other. So look at marriage, right? Being married, being single, divorced, widowed, etc. There's no ranking to it. You can't say one is higher than the other. So that's an example of a nominal variable. The same with gender, okay? Male and female, there is no order to it. So that's an example of nominal. Now the other type of qualitative is ordinal. Now here, it's the opposite of nominal in that there is an order. So let's look at a categorical variable here. Now remember the other categorical variable was education. Now here there could be an order because you can't get a master's without having to do your degree, or and you can't get a degree without maybe having a diploma, etc. Right? So there is an order to it, that where one is higher than the other. You can say that uh, the one qualification is higher than the other. So this is an example of an ordinal qualitative variable. All right, does that make sense to you? Okay, so now make sure that you understand qualitative variables using these examples. So now make sure that you get that before I move on to the other type of variable. Okay, cool. Thanks, thank you. All right, I'll move on to
So, if I may just ask, will the limit balance on your credit card be an example of ordinal?
no, that the limit balance is, and I'll explain that in a second. I'm getting to that part. That's a quantitative variable. So that's the next part I'm going to cover. So the limit balance does not fall under categorical. The only variables that will fall under categorical are these three that I'm highlighting here. It's gender, education, and marriage. Does that make sense?
Okay, yes.
Okay, fantastic. All right. So let's move on to the next type of variable, quantitative. Now, quantitative, you can get, they fall under ratio and interval. Right? I'll explain the difference in a second. I'll explain interval last. All right. So you get ratio, and then this ratio can be broken up into discrete and continuous. Right? And these are pretty easy to distinguish, right? So you get discrete and continuous. All right. Now, how do you know a variable is quantitative or qualitative? Well, let's look at this example here, right? This is what you can use to determine if it's quantitative, right? If you can average the marks, not marks, if you can average that column and it makes sense. So let's look at credit card usage. If I just took, let's say, the first 5 people, right? And if I looked at their credit card usage, for instance, right? If I add them up and I divide it by 5, that will give me the average credit card usage. And that makes sense. That makes logical sense. All right. Now, if you can get an average from that variable, in this example, this column, then that means that that variable is a quantitative variable, right? Now let's look at an example as education. Now we know education is categorical, that it's qualitative. If I had to average the education for the first 5 people, that's not going to make sense, right? Because one person having a diploma and the next person having a degree and the third person having a master's, if I average those numbers and I get, let's say 2.5, then that doesn't tell me anything in terms of their qualification. That doesn't make sense. So the average doesn't make sense. Right? When you do any numerical, or should I say, an algebra function on that variable, if it gives you a non-sensible result, then that variable is not quantitative. But if it is a sensible result, then it is a quantitative variable. So there's 2 columns here. I would actually say there's 3 columns that are quantitative. It's your limit balance, because if I get an average for this, it would make sense. It'll also make an average for age. I mean, it'll also make sense if I took an average age. If I took everyone here and I average their age, that average number would make sense, because I can say that the average age of people from the study is that, and the same thing for credit card usage. All right, so that's how you determine whether it's quantitative. So that's how you can determine whether it's not qualitative and it is quantitative. So you know you fall here. Now, those variables can be further broken down into a discrete variable or a continuous variable. All you need to know for discrete variables is it's a whole number. You can think of it as a number that doesn't take decimals. And if you look at this example here, age doesn't take decimals. I don't think any of you will complete a form saying I'm 34 and a half years old, or 38.25. Almost everyone captures their age as the nearest number. Um, Whenever you see that the variable is numeric, but it doesn't take decimals, then it's discrete. And then the opposite is true for continuous. If it does take decimals, like for instance here, you're talking about money. It can take cents, so it's points or comma, that value. Another example is temperature. You can take decimal values, so that's continuous. So I hope you understand the difference between discrete and continuous. And I've showed you how to differentiate between qualitative and quantitative. Um, does that make sense? Are there any questions on how to differentiate these variables? I said I will do interval loss. I'll get to that in a second. But I just showed you how to identify whether it's quantitative, and then further to identify whether it's discrete or continuous. Any questions before I move on to the last one, which is interval? Good. I hope I didn't lose you. I know it's quite late. This is the last one, everyone, so just bear with me. Okay, fantastic. All right. The last one is interval. All right. Now, let's say you were filling out a questionnaire. Now, the questionnaire didn't ask you to fill in what your salary is. The questionnaire gave you these options. So it says you make between 2,000, right, 2K, and 10,000. Okay, so let's say you fall in this bracket. And if you look at your SARS tables, you'll generally see these tables here, all right? And then it says, okay, if you're not in this bracket, then maybe you're in, I'm gonna put a round bracket. The round bracket basically means you're not including the 10K. So if you were 10K, you would fall in this bracket, right? The round bracket means even though 10K is here, it means you don't include that, right? So if you even a cent more than 10,000, you're in this bracket. So 10K to let's say 20K, and I'll do one more bracket here just to make it easier for me. And then you got 20K and over, and I'm going to put infinity here. So you make anything more than 20K. Let me change it. I don't like the way I wrote infinity. I'm going to write 20K plus. So if you make anything more than 20K, then you're in this last bracket. Okay. Now here, these are numbers, all right? Even though they're bracketed, but they're in intervals. Okay, so even though your salary, like if you add 4 people's salaries up and you divide it by 4, that will give you an average salary. That would make sense. That makes logical sense. So it is a quantitative variable. But the thing is, it's given to you in intervals or in brackets or in ranges. And in that case, it will be an interval variable. So that's an example of interval variable. Okay, and that's it from my side. I'm hoping, yeah, that made sense to you. If there's any questions, please let me know. I'll make the recording available. Just a note, I will give you some reading to do for this week and next week. I am away next week, so it's only next week that I'm away. So if you hear the silence from me, please understand. But I'll get back to you as soon as I'm back at the end of next week. But there won't be a collab next week because I'm away, and then we'll resume afterwards. I will touch base with you via announcements, but in the meantime, if you can, drop me an email before Sunday this week, and any questions that you have, anything you want to know, and I'll get back to you. Yeah, are there any questions? Thanks, Marty. Yeah, thank you everyone. Thanks for joining. I know it's late, and I appreciate it. And we will chat soon. I hope this helps. Have a good evening, everyone.